Hi everybody. Here we have an example of translational motion of a rigid body where a pickup truck has a ladder with the properties shown: mass, length, and the angle, and the ladder is supported in such a way that it rests against the tailgate array and makes contact with the roof at point B. Um, the distance between point A and B is 2 meters. The question is, what is the maximum acceleration the truck can have such that the ladder will not lose contact with point B? Or another way of looking at it is, what is the acceleration the truck can have so that the contact is about to be lost between the ladder and roof of the truck? So let's look at a free body diagram of the situation before writing any equation. On free body diagram, the key forces are weight of the ladder mg acting at center of the ladder whose length is 6 meters, therefore I have 3 meters here, and the distance between A and B is 2 meters, so I have 2 meters here and 1 meter between center of the ladder and where point B here is. So other forces that I've shown on free body diagram is the normal force exerted by the roof of the truck on the ladder at point B. I'll call this force N, and I showed the two reactions at the bottom of the ladder as two forces, AY and AX. So these are all external forces acting on the ladder. Now the truck is moving to the right with acceleration AX, so on mass acceleration diagram I want to show vector MAX, and at the threshold moment when the maximum acceleration causes separation of the ladder from roof of the top, normal force goes to 0 at maximum acceleration. In other words, when the ladder is about to rotate upward, at that moment normal force separation occurs, therefore normal force goes to 0. So basically what I'm after is determination of acceleration AX based on equations of motion. Now generally speaking, for a two-dimensional problem I have three equations of motion: net force in x direction equal to max, net force in y direction equal to ma sub y, and a moment equation to be used with respect to any point that is appropriate. Now if I take moment about mass center C, I have a net moment equal to I alpha in general, but since the truck is moving in a straight line, has a translational motion, alpha is 0, and I have net moment about C equal to 0. But observe that if I choose moment about point C, I have two unknowns AX and AY which do have a moment about point C. So alternatively, I choose to find moment of all forces about bottom of the ladder, which is point A. So let's label this as point A. Now I need perpendicular distances for finding moment of the forces. This angle is theta, which is known as 35 degrees. This is theta. This distance is 3 meters. Acceleration max acts in the middle of the ladder, which is 3 meters away from point A. So then this perpendicular distance is 3 sine of theta, and the distance between weight mg and point A is 3 cosine of theta. So if I write this moment equation, sum of Moment of all forces about point A on free body diagram must be equal to sum of moment of all vectors about the same point on mass acceleration diagram. And I choose clockwise to be positive. Yes, clockwise to be positive. Typically, we choose counterclockwise to be positive in accordance with the right hand rule, but here I wish to make this choice to have a positive sign on the right side of the equation. So, moment of all forces on free body diagram, neither AX nor AY have a moment about point A. The only force that has a moment about point A is mg, whose moment arm is 3 cosine of theta. And since I'm choosing clockwise to be positive, this is a positive moment. Normal force N is 0, so I continue by completing the right side of the equation, which has moment of inertia vector max about point A, whose perpendicular distance is 3 sine of theta times max. Note that mass m cancels out from both sides of the equation. 3 also cancels out. I can solve this equation for ax, which turns out to be g cosine of theta divided by sine of theta, or simply g divided by tangent of theta. Continuing with numerical calculation, ax turns out to be 9.81 divided by tangent of 35 degrees, and this gives us a numerical value of 14 meters per second squared. So that is the acceleration of the block when rotation of the ladder in counterclockwise direction is imminent. In other words, this is the maximum acceleration the truck can have in order to cause separation of the contact at point B, separation of the ladder with top of the roof at point B.